Right. Any questions, comments?
Okay. Have I stopped sharing as far as you can tell?
It still shows you are sharing screen.
I'm
But we
still
see you
sharing.
like in
Okay.
a little.
Okay.
Now we see you. Perfect. Right now we lost you. Okay, now we see you. Perfect. All right. Questions, comments? Yes.
So,
Wait 1 second.
oh,
Here.
oh, thank you. Oh, awesome. Thanks. So, Amy, in your talk, you said that one way forward is an algorithmic approach as to what should be done. And you gave examples like what to do with outliers. I guess my question to you is a two-part one. The first is, what does such an algorithm look like in your mind? And this kind of, meta analysis, or, what is the algorithm? What's its goal? What is it doing? And then my second question is, given the first part of the talk, why an algorithmic approach as to one made by experts?
Well, so first one, there are a couple of one of the main things you want people to do is not cheat, whether they're doing it consciously or subconsciously, because even people who don't think they're cheating have the ways unconsciously they want things to turn out. And that's a very hard thing to avoid, especially with observational data, because there's a limit to blindness, for example. You can do an observational data set, because everybody knows treatment is. And so it would be trying to be systematic about cutting off any obvious avenues to somebody being able to get the results they want consciously or unconsciously. I think it's I don't think I have time now to go into some of the ideas I would have about doing it. But that's that's the criteria. The other criteria is to be sure that the methods you're using are methods that are under whatever assumptions you're making would validly reproduce causal effects if in fact there were causal effects. I mean, some of the things I would do is, like many things, they're doubly and multiply robust estimators. People usually say use a doubly or multiply robust estimator. However, which I agree with, but however, using estimators like the G formula that only depends on the outcome regressions, or using things like inverse probability treatment weighted estimators that only uses the treatment probabilities, I think it's good. Those should be reported as well, because this has nothing to do with causality. In the absence of misspecification, all three have to give the same answer. So even though the doubly robust is better, it would also be nice to know why, if let's say the inverse probability weighted estimator was giving a different answer, why it was, because that means there has to be misspecification essentially in the treatment probabilities, and to try to understand how that happened and what's going on. So in other words, there are lots of ways to try to look at the data from as many ways and not just rely on one approach. So you believe what you did more than you would otherwise. That's all.
Right. Thank you. Yeah, I have a quick question for Raaz. So you said you built confidence intervals for these individual treatment effects, right? So often in causal inference, we're interested in either average treatment effects or conditional average treatment effects. So based on some covariance that we've also observed, is that something that you can incorporate in your approach with a simple trick on top of that, or is it something more challenging?
Yeah, that's a great question. So currently, no. The simple answer is no. We provide confidence intervals conditional on the users, and we don't have joint confidence intervals across all the users at the same time. So the short answer is no. And we are thinking of how to give confidence intervals on average. And so currently it's not a simple trick on top of what we have done.
Great, thanks.
Yeah, so in simple words, it's marginal confidence interval for each user.
Any?
Hi, Jimmy.
What?
Enjoy your historical review
Hmm.
about the history. So follow up on Chris' earlier question, I would think that you agree that this algorithmic approach, you also need human in the loop or human oversight. Could you elaborate on what type of human involvement you would like to see in the system? You wouldn't want it to run completely by itself.
No, I don't. That's why, that's what I meant by not completely algorithmic. What I would like to see, I think the greatest thing would be disinterest. Even more equally important would be having people really skilled doing it, who are used to seeing all the ways errors can go wrong. Third thing would be not having interested parties doing it, which is, of course, the biggest problem in science, because and there are not many mechanisms, or again, scientific kudos for having disinterested parties analyze data, not in a vacuum, but with input, but no control from subject matter and methodologic experts from each side. So again, if I had all the resources in the world and could get things, organize things as I wished, I think just starting with those things, you could make a huge difference based on those principles. But I don't know how to get those principles enacted. What do you think? What do you think? I'd like to ask you the same.
I definitely agree that the impartial, like third party, but then these people also have to be well trained.
Yeah.
So that makes it probably impossible to be completely partial, but at least like with set proposals, you want a few degree removed.
Mhm.
So that can be done, like cannot be collaborator, cannot be former students, and all of that, I think can be done. And also there has to be some metric for the system to flag, because human cannot be watching all the time. So you need to have some automated like flag and human investment, also probably a committee in this oversight instead of just one person. I will add to what you said. And also documentation, you already mentioned that, and some automatic algorithm can also go through the documents and also do some natural language processing, I would say, to help to summarize things. More like human-machine collaboration. That makes sense.
Good, I'd agree.
All right, thanks. Any other?
So I think it goes to both, because you both talked about, so Raaz, you talked about adaptive experiments and personalized experiments, and Jamie, you talked about validation through trials. When we go to more like personalized effect and heterogeneous effect estimators, what are your thoughts on validating through stratified trials, for instance? And how can we maybe change our estimators to target validation for through such trials and things like that?
Who wants to go first? Yeah, so I think, those are hard questions, because there's two things. Trials are usually too small to document complicated choices of optimal regimes. I think the best, I think one of the ways, everybody has a lot of ways of thinking of merging observational with randomized trials. I think if you do have good observational data, a large observational data set, I think a reasonable thing to do would be to do your very, complicated method of choosing an optimal treatment strategy, hopefully one that has some interpretability on the very big observational data set, but don't choose one, choose like 10 or 5, and then just analyze those 5 particular regimes, as well as the usual, everyone take treatment, everybody don't, and estimate their value on the randomized data, and just see if a couple of them are better, because I think you can't do much more with often the size of randomized trials we have, and maybe compare 5 or 6 regimes. So maybe use observational data to choose them, and then they may not be the best, but at least you'll get the best of the 5 or 6 you try. This may not be a great answer. I'd be interested in better answers.
Oh, no, I think I agree with what Jamie said. I don't have as much experience as he has. So no, I think actually I have a question on the other end. Like you said, we need good trained experts involved in the analysis. So that also raises a question: how do we train good people, right? Like in machine learning nowadays, we have a lot of data sets and algorithms that are widely available, and you can see people learning those. In causal inference, like I don't see that much of medical records for obvious reasons. So how do we train good experts in causal inference? Like if the data that are the challenging ones are not going to be public, like do you have any thoughts on that or some resources on that?
Well, I think the de-identified data needs to be public. I guess I think there needs to be competing analyses with different methods with criticism. I mean, it's the usual thing. You can't learn how to aim unless you know when you miss and when you hit the target. So just saying I did this method and that's a good method ultimately doesn't teach you anything unless you find out if to breed with other methods, whether you breed with later, follow-up studies and science and so forth. So I think it's this is what it means to create a discipline, I guess. I mean, yeah.
Thanks. Any other questions for Marx? Okay, I have a quick one, mostly for Jamie, but also a bit for Raaz, because he's been in groups and might have a strong opinion on these things. So so Jamie, you mentioned this multi-world analysis. You should do different ways of pre-processing, use different methods on the data, and then report not just one analysis, but maybe like 5 or 10 analysis. Now, I see a bit of an issue with that. If you think about it from there's a decision maker on the other end, might be like someone in politics, and they want to see maybe 2 or 3 numbers. If you give them 10 or 15 numbers, they might A, get confused, or B, just like say, oh, you can't really say anything, so I'll just go with my gut feeling here. So there's an issue with that. Our job as a statistician is also to summarize and simplify decision making. And like, where do you stand on this? Like, and should we kind of be honest and just like report everything and add complexity, or should we simplify? I don't know. This is open-ended, so I don't know myself.
First, the example, I mean, that's a good question, but the specific example I was saying where you should do 5 or 6, I meant to offer 5 or 6 hypotheses to the randomized trial, where if you have the time-dependent covariates and so forth, you can estimate from randomized trial data where there was no confounding. I was just saying, here are 5 or 6 regimes I picked out of an observational study. Now run them through the randomized trial. From the randomized trial data, estimate their means under these counterfactual means and choose the best. So that was just a specific to get 1, not to do 5 or 6. The general question you're asking, I don't think there's a simple answer to it, because I think that this idea that we hold all this information that if we give too much to decision makers, they'll have a problem with. Well, okay, that's probably true. On the other hand, we're almost never in a setting where other people who are also called themselves experts agree with us. There'll always be disagreement. So if you take that strategy, it all's going to end up being political. That is to say, they're going to be competing groups with power and money, and they're going to get the experts they want. And so this idea that there's some group of experts who can talk to one another and say, well, there's some uncertainty, this is the best thing to do for a decision maker to decide, is, I think, not realistic in a, in a politicized society like we live in. Which means it's pretty hopeless, but anyway.
Okay.
Good question from the chat.
Question from the chat. Yeah, but maybe Raaz.
Oh,
before you-
yeah, I mean, I think like it's a great point, and I have been hearing that, again, as you said, being in Ben's group, it was very helpful. Like we have to have a good communication. Like you have, like there is stability in the scientific analysis, but there is also this stability in communication. The word, like particular word in one domain may not mean the same to the other. So we need to have some kind of simple understanding, like we have to have some common grounds. And for that, I think it needs time and training, and we have to have some simplified pros and cons list in the language that the people understand. So I think the scientific community here probably wants to take a step towards trying to communicate better, like tell them that this is what we think the study suggests, this is the worst case, this is the best case, like in a language that a common man will understand. So I think there is some, in my opinion, there is some onus on us to communicate better and not, to put it like naively, live in our own la-la land. So yeah.
Great, thanks. So I'm now reading a question from the chat. It's a question for Jamie. So suppose we have a body of RCTs that are known to be unbiased and a body of observational studies with ex ante unknown bias. What sort of pooling assumptions do we need to actually learn something new from the observational studies? Is there in fact value? I gotta scroll. Value in devoting resources to calibrating observational studies when RCTs are possible. So the last sentence was, is there in fact value in devoting resources to calibrating observational studies when RCTs are possible?
I guess depends a lot on how the RCTs were done. My experience is that even if RCTs have been done and they're good ones, there are so many questions that in the next year, 2 years, 5 years, 10 years will arise about specific groups, specific details of how the drug was given, when people took it, when they didn't, that where there won't be data available in the trials as they were run, and there might be an observational databases that there are always important questions that will be left for observational data to answer, because there won't be trial data. But the fact that there are trials is a great advantage because of the benchmarking to, because you better get the questions pretty much right that the trials came, the answers the trials came up with before you try to extend them. But I think rarely are trials as definitive as the picture you were painting, just because of the way the world is.
All right, thanks. I think you have a question.
So I just want to see if I have an intuition about what you're saying. It's more directly. I know I suppose we can get objectively qualified domain expert in epidemiology that works at Sandia Lab. If I know that they don't have an understanding of, let's say, pinyin, maybe I can develop an algorithm that will help them evaluate the run critical trials of the domain experts that are objectively good actors who do have an understanding of pinyin and not help them do their job.
That was, to me, I couldn't quite hear it. Sorry.
Okay, well, does anybody in the room know what pinyin is? Okay. Well, there are some people in the room that do, right? Yeah. Okay. So do you understand why if I don't know p-mean, I can't analyze a randomized clinical trial? I don't know it. It's hard for me to analyze a random critical trial from a lot of the world's best doctors. Does that make sense?
Okay. Yeah, I think we're running out of time. Yeah, let's thank our panelists, Jamie and Raaz. For a fantastic discussion. Yeah, also thank you very much for the organizers for organizing everything today. Yeah, what else is there? What should I say?
Dominic, for actually chairing. Yeah, so yeah, we are all set for having a nice reception outside. So please join us and continue the discussions outside. And tomorrow morning at 9 is again coffee outside, and at 9:30 we're starting in here again. Great. So see you outside with wine and food.
Jamie, are you in Berkeley?
Yeah.